Okay, start recording. Now, figure 4 shows the displacement of the particles in a transverse progressive wave against the distance from the source at a particular instant. Particular instant. See, as that means particular instant means at certain time. At certain time. That means at certain time lah. So that means this is a y versus x graph. Correct lah. Yeah, yesterday we learned y versus x graph happen at certain time, isn't it? Given time kan? Given time. Yeah? Look at the notes. Now, y versus x graph at any particular time. At certain time. Okay? Shows the displacement of all particles in a wave. You can see the whole wave. Y versus x graph, you see the whole wave. Whereas y versus time graph see only one particle. Oscillation of one particle over time. This one, y versus x graph, shows the whole wave at certain time. This one show oscillation of one particle at certain distance. This one is at certain time. Yeah, shows the whole wave at certain time. You can see all particles here. So this question is against distance. So this is a y versus x graph. Y versus x graph, you see the whole wave at t1 equal to, don't know lah, yeah, at certain time lah. So you see the whole wave actually. Y versus x graph, you see that? See the whole wave. Many particles. Lazy to write. Draw all. Okay. Getting lazier. Now, write down the points where speed of the particles is 0. As I told you, this all of these particles, they are oscillating, and they're oscillating. So we know that, yeah, we learned before. Yeah, we learned before in the simple harmonic motion. Yeah, in the simple harmonic motion, you see the block, oscillate. This one oscillate up and down. Yeah. So at at here. Yeah. So for example, like at this position, the velocity is maximum, kan? At this position, velocity is 0. At this position, velocity is at amplitude. At amplitude, velocity is 0. At equilibrium, velocity is maximum. So same thing goes to this many particle here. So at this position, this is when y equal to 0 at equilibrium. The velocity here is maximum. Velocity is maximum. Maximum value is a omega. Correct or not, class?
Yes, sir.
Bagus. Sangat kuai kamu semua orang, ya? Sangat kuai. Okay. Kalau di sini y equal to amplitude, velocity kembali minimum. Velocity become minimum 0. Di sini juga y equal to negative amplitude, velocity also become minimum 0. So all of these particle, for example, like particle Q, this oscillating up and down, up and down, up and down, up and down, up and down. And okay, it's oscillating lah. It's oscillating up and down. So at amplitude, velocity 0. at equilibrium at velocity maximum a omega. This one y is minimum at this one y maximum at amplitude, y maximum at amplitude. Yeah. So velocity dengan displacement adalah terbalik lah. Bila y minimum, v maximum. Bila y maximum, v minimum. Write down the points where speed of the particles is 0. So which point? Which particle? Which particle? Which particle? V is 0. Which particle? Apa? P dan R. QST paling laju lah. QST paling laju. P dan R ini paling, dia tak bergerak pun. Dia is about to change direction. Moving to the downward. Okay. So the answer is P and R. P and R. Yeah, is velocity 0. Now, write down the points where velocity of the particle is opposite to each other. Opposite to each other. So, what do you think? Which Q and S. That's correct. Let's draw. Kalau P and R, is it opposite? Tidak. Velocity 0 means no direction. Dia stop. P dan R tak boleh cakap dia berlawanan. I mean, pada masa ini dia tak bergerak. Ya, V0. Ya. Dia tak ada velocity. Dia tak ada velocity pun. P dan R tak ada velocity pun. Tapi Q dan S ada velocity. Kalau let's say lah gelombang bergerak ke kiri. Let's say gelombang bergerak ke kiri, gelombang bergerak ke sini, sudah kan? Okay, so partikel ini dah bergerak ke bawah. Betul tak? Partikel S dah bergerak ke atas. So lawan arah kan? Betul tak? Ini ke bawah, ini ke atas. Betul tak? Ini ke bawah, ini ke atas. Okay, mungkin let's kalau dia gelombang bergerak ke kanan macam mana? Kalau gelombang bergerak ke kanan macam mana? Q ini bergerak ke atas. Dan S ni bergerak ke bawah. Lawan juga kan? Betul tak, kelas? Betul. Gelombang bergerak ke kiri atau ke kanan. The wave move to the left or to the right. Positive kx or negative kx. These two particle Q and S still opposite. See that? Always opposite. So maybe we just make. Did he say wave move to which direction? No, no, So never mind lah. Just put as wave. Let's say move to the. Let's say wave move to the right. Wave move to the right is negative kx. So Q and S opposite. See that? Q go ke atas, S bergerak bawah. T pula macam mana? T bergerak ke atas. Okay? Okay, so which one direction opposite? Q and S lah kan? Dan S dengan T. Betul? Ada dua pair. Q and S, S and T. Boleh tak, kelas?
Boleh.
Ya. Write down the points where particles are in phase. Which one are in phase? In phase apa maksud? In phase maksudnya macam sama fasa. Ataupun same direction lah. Same direction, same displacement. Same direction. Gerak sama-sama, In phase is like gerak sama-sama.
UNT
kan in phase. Menurut perintah macam tu, in phase. Tidak lawan cakap. Macam anak kita kalau dia in phase dengan kita, so kita you in phase, kita happy lah kan. Kalau anti phase tu, lawan tu, marah lah kan. Ya, gerak sama-sama, in phase. In phase. Macam you berkawat kan. You mesti berkawat ya, partner kamu dengan team semua mesti in phase kan, betul tak? Itu kaki kena angkat sama-sama kan, sama tinggi kan. Tabik sama-sama kan, betul tak? Pernah berkawat tak?
Betul, Ustaz.
Siapa di sini ada badan uniform dulu? Ada kan?
Pernah.
Pergi berkawat. Kamu tahulah kalau berkawat tu mesti in phase, betul tak? In phase. Kalau in phase itu you tak boleh anti phase, tak boleh lambat sikit, tak boleh laju, tak boleh lebih laju daripada orang, kamu tak boleh lambat daripada orang, you mesti gerak sama-sama. In phase ni macam like kawat kaki. Kawat kaki in phase. Gerak sama-sama. So it's like, this same displacement, same direction. So, okay, which one they are in phase? Which point are in phase? Is it P and Q in phase? Tidak. Kita lukis gelombang bergerak ke kanan sikit, kita dah nampak dah. P ini bergerak ke bawah kan. Q bergerak ke atas, dia tak in phase lah. Not the same direction. Q dengan S, is it in phase? No, they are anti-phase. Anti-phase. S dengan T anti-phase juga. Yeah. So we can say like this one just now here. These two pair, they are anti-phase. So, tapi which one in phase? Which two particles are in phase? Class?
Q and T.
Q and T. Same displacement. You tak P dengan S tak lah. Ya? P dengan S different displacement. You see that? P and S different displacement. Dia mesti same displacement. Macam Q and T both at equilibrium. Both at equilibrium, and then they both move at the same direction. Q naik, T pun naik. Sama-sama naik. Nanti sama-sama turun. You boleh bayangkan tak? Q dengan T ni sama-sama naik, sama-sama turun. Ada tak? Ada tak? Let's look at animation. See that? This one, so many things here. So many things here. I cannot see carefully. So, see these two? Can see? I see. Wait. Can you? Tak boleh nampak dengan bagus kan? Cannot, yeah? Cannot. That's very hard to see lah. Yeah, I need very hard to see. But never mind. You understand what I'm saying actually. So Q and T, they both naik sama-sama, turun sama-sama. Okay? So the answer is Q and T. Yeah? They are in phase. They are in phase. Q and T, they are in phase. Okay? Tapi kalau Q dengan S, dia anti-phase lah. Kalau ini naik, ini turun. Nanti ini turun, ini pula naik. Macam itulah. Yeah? So what I can say is bila bila Q and T ni dia adalah difference 1 lambda. You see that? Q dengan T dia jarak beza 1 lambda, isn't it? 1 lambda kan kelas, betul tak? 1 lambda. Kalau 1 lambda difference is in phase lah. Kalau half lambda, you see, half lambda dia anti phase. Ini difference half lambda. Kalau difference half lambda itu dia adalah anti phase. Faham ke kelas?
Faham je.
Saya terlalu lambat kah ni? Perlahan saya explain kan? So if the time required if time required to complete one cycle is 0.25 seconds, what is the speed of the wave? What the time required to complete one cycle? Okay, so what is this? Time required to complete one cycle 0.25. Apa maksud? What is 0.25 ini? Time for one cycle is apa maksud?
Period.
Period. Bagus. Period. Period. What's the speed of the wave? How to find speed of the wave? So speed of the wave, apa formula dia? Apa formula dia? Wave propagation speed velocity, apa formula dia?
Lambda over period.
Lambda over period atau F lambda lah, kita selalu guna F lambda kan. V equal to F lambda. So F ialah 1 over period kan. Boleh gantikan 1 over period ke dalam kan. So lambda ada tak lambda? Mana lambda? Q ke T ialah 1 lambda kan? So berapa? So be careful with the, you see, unit. See the unit? Between Q and T is 1 lambda, betul tak kelas?
Betul, Sir.
So dia bagi tahu X dia dalam sentimeter. So dan lambda dia berapa? Lambda dia ialah 1.2 minus 0.4. That is 1 lambda, yeah? From here to here is 1 lambda. Okay? 1 lambda. So berapa tu? 1 lambda is 1.2 minus 0.4 berapa? 0.8 centimeter. Unit dia centimeter. Kalau amplitude, contoh amplitude apa? Amplitude kena tengok Y kan? Y. Dia dalam unit milimeter. Lain dia punya unit. Hati-hati. Soalan ni tak tanya amplitude. Tapi kalau tanya amplitude, dia kena bagi unit milimeter, bukan sentimeter. So amplitude dia ialah 10 millimeter. So hati-hati ya kelas. So amplitude dia bergantung pada Y. Lambda dia bergantung pada X. Macam dulu saya cakap. Kalau X kita bagi lambda. Kalau Y bagi amplitude. Ya, amplitude bergantung kepada unit Y. Lambda bergantung pada unit X. Okay, kelas? So lambda depends on unit X. Amplitude depends on unit Y. So lambda is 0.8 centimeter. So be careful with the unit. Check the unit at the axis. Check the unit betul-betul. So it's 0.8 centimeter. It's not meter, it's centimeter. So lambda is 0.8 centimeter over period is 0.25 second. So what's the answer, class? .2 centimeter per second. Is that the answer? Question 10. 3.2 exponent negative 2 meter per second. Centimeter per second. Correct lah. P and R, Q and T. Correct. The answer is correct. Okay, class? Boleh faham? So far so good?
Boleh, sir.
Boleh, sir.
Boleh ya? So itu saja untuk pelajaran untuk hari ini. Okay, that's all for this question.